Welcome to Table for 92, element number 89, Actinium. It's number 89 because it has exactly 89 protons within its nucleus. For Actinium, I want to talk about the contribution of the French in the discovery of radioactivity and, their contribution to cuisine, of course. It's the whole Belle Epoque period, which refers to the art scene going on in France between the Franco-Prussian War and World War I. A lot of very important things happen in that 43-year period. It's hard to understate. Technological advances, artistic revolutions. This is when soccer swept the world, the discovery of germ theory, relativity, radioactivity, the telegram, mass media, electricity, actually being used to make life a little easier. It's the height of colonialism. It's really the invention of the modern world. And that also included modern high-end restaurant culture. I'm sure it's no coincidence that the discovery of germs was followed by the first real professional kitchens in the world. So yeah, the OG of modern French cuisine is Auguste Escoffier. He invented the whole brigade system that pretty much all high-end restaurants use today, where every chef in the kitchen has a specific role and the whole thing operates as a symbiotic relationship. But yeah, he also brought about the idea of a clean kitchen. Before Escoffier, restaurant kitchens were kind of known as being dangerous, dank, kind of gross places, whether it was in a duke's castle or a country roadhouse. And chefs were not held in high regard back then. This is the transition of kitchens being held in the same level as cathedrals and chefs being celebrities. That really started with Escoffier. So I'm cooking up arguably his most famous creation and arguably the most famous dish created in the Belle Epoque, a dessert called peach melba, invented by Escoffier while working in London, and it's dedicated to the opera singer Nellie Melba. Interesting to note, Escoffier named a ton of dishes after beautiful women he encountered while working at the big fancy hotels of the day, but no recipes he made up were ever named after his wife. So this recipe for peach melba is taken right from the Auguste Escoffier School of Culinary Arts website. I'm going to change a couple things just for my own personal taste, but this is going to be worthy of the likes of Nellie Melba. So first thing is to make caramel. In a saucepan, add 65 grams water, 250 grams sugar, and a splash of corn syrup. Cook on medium heat until that gets blonde. You get that nice Maillard reaction going. Then reduce the heat to low, add 65 grams unsalted butter in small pads, and the caramel is going to splash a little and foam when the butter hits it in the pan. Pit and cut 3 medium yellow peaches into small pieces, 8 slices per peach. Add those to the saucepan with a large slice of lemon peel and a thumb of smashed ginger. Cook that for 5 minutes, stirring a couple times, and then remove that from heat and cover for another 5 minutes. That will complete the peaches cooking. So I really can't understate how incredible it would have been to live in this time. Life was rough all over the world, but there was this sense of optimism about the future, all built on the back of scientific achievements. The most famous people in the world in this period, in the late 1800s, early 1900s, were scientists, and they were treated like modern-day pop stars, something really kind of unfathomable today. Marie Curie or Albert Einstein, they could have sold out theaters back then like Taylor Swift does today. Easy. Okay, so actinium, it's radioactive. There's no biological role for it in the human body. It's a silvery metal, and there aren't a ton of uses for it outside of research. We might use it in the future. Remember that with the rare earth elements? They were completely useless and little more than a curiosity until we figured out they made great magnets, and now they're in every single smart device in existence. And yeah, with a lot of these really heavy radioactive elements, they're just so radioactive, they've pretty much disappeared from Earth through radioactive decay. Think technetium or promethium. That's why these elements were among the very last to be discovered on Earth, because we had to discover and define radioactivity before we can even attempt to figure out the process in which they could be discovered. So there was the accidental discovery of X-rays by the German chemist Röntgen. That really started nuclear physics. He hilariously tried X-rays out on his wife without telling her what to expect. And then when she saw the outline of the bones in her hand, she thought she was seeing her own death. Just hilarious. What a great prank. Today, that would be all over TikTok. Everyone would laugh. It'd be great. But yeah, Roentgen discovers X-rays, doesn't know what's causing them though. Like, complete accident. That's why they're X-rays, they're unknown. It got passed on to the Frenchman Becquerel, who was able to explain the phenomenon, and Marie Curie then came in and actually coined the term radioactivity. Then the Curies were able to extract radium and polonium from pitchblende, a uranium ore. That was a really arduous task. Like, at first it took them 10 tons of pitchblende to extract 1 milligram of radium. This all happened in 1898. The next year, a friend of the Curies, André-Louis Debrunay, also used pitchblende to extract number 89 and named it actinium from the Greek word meaning ray. Great, right? Well, not so much. He probably didn't discover 89. There were so many of these discoveries back then that were later debunked, especially with these super rare radioactive elements. There's quite a bit of confusion over who actually gets to claim the discovery of 89. While Debrunay published his findings in 1899 and 1900s, we now think the methods he used could not have possibly resulted in discovering a new element. There's a great quote actually from Robert Bunsen, who is the guy the Bunsen burner is named after, and who, along with Gustav Kirchhoff, invented spectroscopes that would help, scientists to discover a bunch of elements. But Bunsen had this to say about all of these discoveries coming out. Quote, "The frivolous way in which new metals are discovered by dozens and sent forth into the world, duly christened, is certainly no gain to science. Only later inquiries will be able to decide what remains new and serviceable out of this chaos of material." He really calls out perfectly. I mean, he was doing this in 1859, 40 years before the discovery of actinium. There were so many claims and complaints going on that it's now historians that have to go back through all of the data, research, whatever, and decide, who gets credit for what. I mean, yeah, we're talking about the mid to late 1800s. It was kind of a paradise for pseudoscience. We have seen enough pseudoscience in the 21st century when we really should be better at detecting that kind of fraud. Anybody remember Theranos? She had Henry Kissinger on her board of directors. So yeah, it was absolutely justified for people to be skeptical about really any element being, discovered back then in the late 1800s. But Debrunay was a close associate of the Curies, who were, hands down the most famous and respected scientists in the world at the time. So, he also got a lot of respect. But we now know it wasn't him. It was a German chemist named Friedrich Oskar Giesel who definitely isolated actinium in 1904. And because of the radioactive bluish color that emanated from the pure sample he was able to isolate, well, really, actually, the blue color is the result of the radiation exciting the air surrounding it. Anyway, he named it amanium, as emanating. But Giesel soon realized the element he had been working on was number 89, but because he was a huge admirer of the Curies, and Debrunay by extension, he didn't press the matter of who got the credit for the discovery and went along with the name actinium, which is really cool of him. A lot of other chemists at the time would definitely have a conniption fit over this. I mean, you get immortalized by the scientific community when you find a new element, but he didn't press it, so good on Giesel. But yeah, there's plenty of other elements where multiple people discovered it around the same time, and I mean, people still argue about this today. So it is really kind of nice of Giesel to have given up his rightful claim to appease some other scientists he really admired, especially since this was 10 years before World War I broke out. A German chemist and a bunch of French chemists, talked a lot about the extreme nationalism in Europe before World War I and how that spilled out into the realm of scientific circles. But, not this time. So thank you, Giesel, for not falling down that rabbit hole so many others had before. While that caramel's cooling off in the fridge, gonna make this sweet cream. 2 ounces cream cheese, 2 ounces feta, and you just mix that together with honey until extra smooth. Whisk it like you're trying to impress a beautiful opera singer in Victorian England. Add just a little bit of heavy cream until it thins out the way that it would be nice and presentable. While actinium isn't really used in anything outside of research purposes, it holds an important place in the history of elemental discovery, I guess you would put it. Actinium is the first element to be discovered that was non-primordial, as in it's the first element that has not been on Earth since its formation. Primordial elements, on the other hand, have stayed in their current configuration since the beginning of Earth, 4.54 million years ago, plus or minus 50 million years. On our wonderful planet Earth, most of the 92 naturally occurring elements are primordial. They were created by stellar development, all starting with the Big Bang 13.4 billion years ago. plus or minus 50 million years. We know this. In the first 380,000 years after the Big Bang, hydrogen, a little helium, and very small amounts of lithium were formed. These are the lightest, simplest elements, especially hydrogen, 1 proton in its nucleus. And so these were formed in the hot, dense abyss of the early universe. But as it expanded, the universe cooled down, and eventually stars formed in the first few 100 million years after the Big Bang. In the core of these massive stars, massive, like 8 times bigger than our own sun, heavier elements formed in their cores, all the way up to iron, number 26. Now, when stars come to the end of their lives, a supernova events where these massive stars, collapse in on themselves, and huge amounts of energy is released through nuclear fusion. That's what created the rest of the naturally occurring elements in our universe after iron on the periodic table, including our subject of today's episode, the really heavy and really complicated actinium. There are 36 isotopes of actinium, all of which are radioactive. The most stable, actinium-227, has a half-life of 21,773 years, while most of the isotopes have less than a half-life of a minute, So yeah, very radioactive, just like technetium or promethium. These elements are just so unstable that whatever amounts of it existed on Earth billions of years ago, they've just reformed into other elements through atomic decay. It's very difficult to understand, but thankfully we had some really kick-ass physicists in the early 1900s that took the time to show number 89 existed on the periodic table. So the discovery of actinium did give birth to the missing row on the periodic table, 89 through 103 where it's separated. These are the actinides, which was added to the periodic table in 1945 by Glenn T. Seaborg. The most important addition to the periodic table since Mendeleev created it back in 1869. So really big deal. And Seaborg, too, if you don't know, he deserves to be as famous as Marie Curie or Einstein. His contribution to science and the periodic table is incredible. He was either head or part of a team that would discover 10 elements, all transuranic, those, that are heavier than uranium, which includes number 106 on the periodic table named Seaborgium. He's the only person to have been alive while an element was named after him. Pretty cool. Unless it's true that Lecoq Bois-Badron actually named gallium after himself. It's possible. Anyway, watch gallium. You'll find out about that. The actinide concept, whereupon he observed the similarities between the actinides that he was in the process of discovering, and the lanthanides, that's, those 2 detached rows at the bottom of the periodic table. He was also a huge proponent of nuclear medicine using radioactive elements and their isotopes to treat cancers, including actinium-225 because it emits alpha radiation, which can kill cancerous cells without hurting the healthy cells nearby. So I know, we've all been looking for the cure to cancer, our entire lives, for a very long time. Is it gonna come from actinium? I have no idea. I can't hang out with those medical journals. It's a little past my knowledge, but I would just like to remind everyone that, nearly all the people responsible for the discovery of these radioactive elements, that are used in cancer treatments today, died from radioactive induced cancers. Overall, actinium is yet to be used in anything outside laboratory research, but, who knows what the future may hold for actinium. So that was actinium, and this is peach melba. Oh my god. I've made it before, but this is so much better. Oh my god. I don't know why. Try making peach melba at home. It's totally worth it. This feta cream cheese mix is kind of funky, but it's really, really nice. It's better than just having straight vanilla ice cream on it. There's a lot going on here. So I hope old Nelly Melba was impressed by this, because I sure am. Thanks. See you next time.